Hello everyone, how are you all? I hope you all are doing very good and studying well with concentration and also enjoying our playlist and learning from our playlists of previous year questions of all chapters of CBSE Class 10 and experimental learning and some concepts of the light also. There are so many playlists created in our YouTube channel for your learning purpose. You just once go and see once what playlists are created and what knowledge can you gain from those playlists. So today I have brought you one more video, very interesting video and very powerful video. After watching this video completely, I am pretty sure that you will not be having any doubt on combination of resistance. Any doubt, you will not be having any doubt on the concept of combination of resistances. It may be it may be series or parallel or series parallel combination or anything. Whatever you need to solve any problem that will be asked on a combination of resistances, that will be given to you. 100% I am saying, after watching this complete video, you will get everything that is required to solve any question that will be asked in the board examination on the concept combination of resistances. Okay, so without any delay, let us start the video. So combination of resistances, what are we going to do in this combination of resistances video is, I am going to explain first the theory of combination of resistances, which formula to use, where to use, series connection, parallel connection. Thereafter I will take some small numericals, very easy numericals of my own examples. Afterwards I will take some previous year questions that was asked in the board examination. Video is going to be a bit lengthy only, but believe me, after completing this video, you are not going to have any doubts regarding combination of resistance at any point of time. Your all doubts regarding combination of resistance will be cleared. So now, let us start the video. Combination of resistances. How many types of combinations are there? How can we combine resistance? We can combine resistance in three ways. What are those? First way will be series combination. Second way will be parallel combination. Third way will be star delta combination. This star delta combination is not there in your syllabus. So you need not to worry about this star delta combination. But you should be knowing completely about series connection and parallel connection. Now what is series connection? Series connection means is also known as end-to-end connection. End-to-end means what? When there are two resistances like this. Imagine this is resistance R1 and there is one more resistance. Resistance is named as R2. This end should be connected to this end. This is the terminals. These two are the terminals of resistance. This end or end. This end should be connected to the next end. Suppose there is one more resistance like this, R3, then this end should be connected to that end. This type of connection we call as a series connection. When number of resistances are connected in series, then the equivalent resistance. What is equivalent resistance? Equivalent resistance means if there are so many resistances connected either in series or in parallel, it is very difficult to draw all the three resistances diagrams every time. So we are going to take equivalent resistance, means we are going to draw one resistance. We are going to draw one resistance. Instead of all these three resistances, we will draw only one resistance. The resistance offered by all the three resistances together will be represented by a single resistance. That resistance we call as equivalent resistance. So series combination, no, so I am going to write as RS. So instead of these three, you can write a single resistance. So resistance offered by these three will be offered by single resistance. So what will be the value of this resistance when connected in series? Rs will be is equal to R1 plus R2 plus R3. If four resistances are there, then plus R4. 5 are there plus R5. Two things we need to know. When different value resistances are connected in series, then R1 plus R2 plus R3 plus R4 plus R5 like that anything. Suppose imagine equal value resistance are connected in series. Equal value means here like this. This is also R, this is also R, this is also R. So equivalent resistance will be how much now? R series will be is equal to R plus R plus R. What happened now? R plus R plus R, 3R. Suppose 4 resistances are connected, 4R. 5 are connected means 5R. 6 are connected means 6R. Like that, if n number of resistances are connected in series, equivalent resistance will be n into R. Okay, na? This is about a series connection. Now, let us come to the parallel connection. What is this parallel connection? Parallel connection. Parallel connection means what? When there are two resistances like this. One resistance and one more resistance. Imagine this is the positive and this is the negative terminal of the resistance. Generally, the resistance has no positive and negative terminal. It will be having, it is a bilateral element. Bilateral element means current can go in this direction or current can go in this direction also. In both the directions, in any direction current can go. So that's why bilateral, two directions. Bi means two, lateral means directions in electrical terms. So bilateral element means what? Current can go in any of the directions, but the property of the resistance will not change. That type of resistances we say it as that type of equipment we say it as bilateral equipment. Resistance is a bilateral equipment, so it will not be having positive and negative. But for your understanding purpose, I have given as a positive and negative. And suppose this is also positive and negative. So when do we say two resistances are connected in parallel? When these two are connected and these two are connected like this. Now this connection is in parallel connection. From here to here we will connect one more line for the connection of circuit diagram. Take this resistance as R1, this resistance as R2. 2 are there. If 3 are there, what happens? One more resistance will come like this. 3 are there means one more, 4 are there means one more resistance will come. So, how to find the equivalent resistance of parallel combination? There is a formula. Means these two resistances can be replaced by a single resistance. These two resistances can be replaced by a single resistance, and that resistance I am going to name it as Rp. Because parallel combination, no? So I took it as R with the suffix P. What is the formula for Rp now? Rp formula is 1 by Rp is equal to 1 by R1 plus 1 by R2. This is the formula. For equivalent resistance when two resistances are connected in parallel. Imagine 3 are connected. If 3 are connected, then 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula for equivalent resistance when 2 or 3 number of resistances are connected in parallel. This is the formula for parallel connection when different value of resistances are connected in parallel. Suppose equal value resistance are connected in parallel, what happens? See once, when equal value resistance are connected in parallel, what happens? Imagine two resistances of equal value are connected in parallel like this and like this. This is R and this is R. What is the equivalent resistance formula? 1 by Rp is equal to 1 by R1. R1 is also R, R2 is also R. 1 by R plus 1 by R. What is the LCM now? LCM is R it becomes 1 by r into r cancels 1 plus 1. So 1 by rp is equal to, I think if you did not understand how did I get to 1 here, I'll explain here. See once, r and r, LCM is r. I'll explain here. Suppose there is a 3, 6. How will you do LCM? 3 1 ja, 3 2 ja. 2 is remaining 1 1. 3 to the 6 is the LCM, correct? So r comma r. This is the LCM we have to take now. I'll take with r. R1 the R1 the R1 the R, R1 the R. So what is LCM? R. R is LCM. Now take this one. 1 by R into R. R cancels. 1 is remaining. This 1 is written here. In the same way here also. 1 by R into R. R cancels. 1 is remaining. 1 is written here. So now it becomes what? 1 by Rp is equal to 2 divided by R. So Rp will be is equal to R divided by 2. When two equal resistances are connected in parallel, the equivalent resistance became R by 2. If 3 are connected, R by 3. If 4 are connected, R by 4. Likewise, if n number of resistances are connected in parallel, then the equivalent resistance will be R by n. Okay now look at these two formulas, this one and this one. When n number of equal resistances are connected in series, what happened? Resistance became multiplied by n. When n number of resistances are connected in parallel, what happened? Resistance got decreased by n. Right? So this you need to remember. So from all these things, what are the things you need to remember? This one, R series formula is R1 plus R2 plus R3 when 3 are connected. And R parallel formula is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This one. And this formula, NR and R by N. This you need to remember. Okay, na? I am not asking you to remember anything, but these formulas, 1, 2, 3, 4 formulas. These four formulas are required to solve problems on resistance, series combination and parallel combination. I hope you all understood the combination of resistances theory. Now let us go into a simple problems. Now I'll take first simple problems. Afterwards I'll increase the complexity of the problems. Then I'll take some previous year questions also. Okay. First I'll take simple questions on series and parallel. And afterwards I'll go with a bit complicated questions. Afterwards I'll go with the previous year questions. Okay. Right. So now let us write the formulas first. Series combination. What are the formulas? Rs will be is equal to R1 plus R2 plus R3 plus and so on. And also Rs will be is equal to N into R. On series combination, nobody will have any doubt. Very simple. Even though we will solve at least one problem. So now 1, 2, 3. Let us take this as 3 ohm, take this as 4 ohm, take this as 6 ohm. What is the equivalent resistance now? Rs will be is equal to R1 plus R2 plus R3. 3 plus 4, 7. 7 plus 6, 13. 3 ohm plus 4 ohm plus 6 ohm. So Rs will be is equal to 3 plus 4, 7. 7 plus 6, 13 ohm. So these three can be replaced. Imagine this as terminal A and this as terminal B. In between terminal A and B, 3 resistances can be removed and you can draw a single resistance now. That resistance value is 13 ohm. This is terminal A and this is terminal B. That is about the series combination. Imagine that only 4 ohm resistances are connected now. Imagine only 4 ohm resistances are connected like this 3. This is also 4 ohm. This is also 4 ohm. This is also 4 ohm. Now what is the formula? This is terminal A and this is terminal B. Now what is the formula? Same formula only. This formula itself, but it will be taken as N into R. N means what? Number of resistances. How many are there? 1, 2, 3. So 3 into what is the resistance value? 4. So Rs will be is equal to 12 ohm. So in between A and B, you can connect a single resistance. That resistance value is 12 ohm. Now let us go to the parallel connection. Parallel connection. What is the parallel connection equivalent resistance formula? 1 by Rp is equal to 1 by R1 plus 1 by R2 when 2 are connected. When 3 are connected, plus 1 by R3. And also Rp is equal to R divided by N when N number of resistances are connected in parallel. Now let us do one problem on parallel connection. Observe neatly. I will solve very slowly such that each and every step you should understand. Imagine that there are two resistances. Resistance, this one value is, let us take it as 12 ohm, and this one let us take it as 6 ohm. 12 ohm and 6 ohm. This is terminal A and this is terminal B. So 1 by Rp, formula is 1 by Rp is equal to 1 by R1 plus 1 by R2. That will be is equal to 1 by, imagine what the children will make mistake is, here it is 1 by Rp. Keep this in mind clearly. You will go on solving this one perfectly, but you will forget that here it is 1 by Rp. What value you are going to get? You have to reciprocate it at the end. See, now I'll explain where you will make mistake also. I'll explain. 1 by R1 is 12 plus 1 by R2 is 6. So 1 by Rp is equal to 12 and 6 LCM. Let us take now. See, 12 comma 6 with what shall we do? 6 2 ja, 6 1 ja. What is remaining? 2 1 comma 1. So what is the LCM now? 6 into 2 into 1, 12. Correct? So LCM is 12. Now you take this fraction. 1 by 12 into 12 is the LCM. 12 12 cancels, 1 is remaining, so write 1. Plus take this fraction now. 1 by 6 into 12. 6 1 ja, 6 2 ja. What is remaining? 2. Understanding or not? I hope you are understanding each and every step without any confusion. So next step, 1 by Rp is equal to 2 plus 1, 3 divided by 12. Here children will make mistake. They will forget that this is 1 by Rp. This every step 1 by Rp they may not write. They will forget to write. Here they will write, and at the end they will write Rp is equal to 3 by 12 ohms. No. Here you have to reciprocate now. If you reciprocate, you are going to get Rp is equal to 12 divided by 3, that is equal to 4 ohm. 3 1 ja, 3 4 ja. Rp will be is equal to 4 ohm. Now let us solve a problem on parallel combination when equal value resistances are connected in parallel. Imagine here, there, which resistance shall we take? 4 ohm. And here also 4 ohm. What is the formula now? Formula is Rp will be is equal to R divided by N. What is N here? Number of resistances. How many resistances are there? 2 are there. Correct? 2. R is the value of the resistance. What is the value of each resistance? 4 ohm. 4 by 2. So Rp is equal to 4 by 2 is 2 ohm. When the resistances are not equal, then you have to use this formula. When the resistances are equal, then you can use this formula for simplified calculation. R by N, Rp is equal to 2 ohm. Okay na? So this is the problems on series and parallel combination. Now let us take a simple construction. Remember, while you solve this problems on this series and parallel combination, remember one thing clearly. This line is there, see, this line don't represent anything. They may give diagram in any type structure. Let them give in any way. Circular, square, rectangular, any triangular, any shape. Suppose there is a resistance like this. Okay. And there is one more resistance like this. Okay. This terminal, it went like this, like this, like this, like this, and it came like this. Sir, what is this, sir? Nothing is there. It is very simple. See, from here, wherever you want to take, you take, but there is no equipment connected, no? So this whole equipment, whole circuit can be replaced as simply like this. This is R1 and this is R2. So this one will be R1, this one will be R2. What will be equivalent resistance now? R1 plus R2. They will use this phenomena. They will construct a circuit diagram in such a way that you will get confused. Wherever there is no equipment connected throughout the wire, that whole wire can be removed and directly connected to the next equipment straight. This you remember. If you remember this, then it will be very easy for you to solve any question. Now let us take a bit simple questions which were asked. First let us take a simple question. Gradually we'll increase the level. Okay. First we'll take simple question, then gradually we'll increase the level. Remember one thing, that when we connect equipment in series, equivalent resistance will increase. When we connect equipment in parallel, equivalent resistance will decrease. So what they asked in the first question, maximum resistance of a network of 5 identical resistances. One second. Now see. Maximum resistance of a network of 5 identical resistance of 1 by 5 ohm. They wanted to find us the maximum resistance. When the resistance will be maximum? When we connected in series. See, here itself it is there. When we connect the resistances in series, resistance will become N into R. When we connect resistance in parallel, resistance become R by N. What they are asking? Maximum resistance of a network of 5 identical resistors. Identical resistors means equal value resistors. 5 are there connected. How to connect and what is the maximum value? When you want to maximum value, you have to connect them in which connection? Series connection. So connect them all in series. 1, 2, 3, 4, 5. This value is also 1 by 5, 1 by 5, 1 by 5, 1 by 5, 1 by 5. So series connected. What are the equivalent resistance when they are connected in series? N into R. N is number of resistances. 1, 2, 3, 4, 5 are there. 5 into R is the resistance value of each resistance. What is this? 5 into 1 by 5. That is 1 ohm. So 1 ohm will be the answer. Okay. This is clear. Let us go to next question. See here what they asked. The minimum resistance which can be made of using 5 resistors, each of resistance 10 ohm. Minimum resistance they are asking. Minimum resistance means what? We have to connect them in parallel. 5 resistors are there. Each resistance is 10 ohm. So 10 ohm is there. Like this 5 resistances are there. Five resistances. See, 10 ohm, 10 ohm, 10 ohm, 10 ohm, and 10 ohm. What is the formula now? R divided by N. What is R value? 10 ohm. That is equal to 10 divided by N means number of resistances. 1, 2, 3, 4, 5. 10 by 5. 10 by 5 is 2 ohm. So answer will be here. Option C, 2 ohm. Now let us find the next. Let us the next question. Three resistors 10 ohm, 20 ohm, 30 ohm are joined in parallel in a circuit. The potential difference across the electrical circuit is 10 volts. Draw the circuit diagram for the above case and find the total resistance of the combination of resistors. Okay, let us find what is there in it. Simple question only. See now, how to draw the circuit diagram? This is not a MCQ now. Let us draw the circuit diagram neatly. Like this, we can take three resistances. You can fast forward this part. Resistance value is 10 ohm, 20 ohm, and 30 ohm. All are connected in parallel in a circuit. Now potential difference across them is 10 volts. So now connect from here to here. Potential difference is 10 volts we told. This will be plus and this will be minus 10 volts. Okay. Draw the circuit diagram over. Find the total resistance of the combination of resistances. How to find the total resistance of the combination? How are they connected now? All are connected in parallel. 10 ohm, 20 ohm, 30 ohm all are connected in parallel, and he also asked to find the current drawn from the same source. Okay, first to find out the total resistance. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. It is 1 by 10 plus 1 by 20 plus 1 by 30. See, 10, 20, 30. What will be LCM? 10, 20, 30. 10 1 ja, 10 2 ja, 10 3 ja. And 2 is 2 comes out and 3 comes out. 10 to 20, 23 is 60. 60. 1 by 10 into 60. 10 1 ja, 10 6 ja, 6. 1 by 20 into 60 it will be 23 is 60. 1 by 30 into 60 it will be 32 is 60. 6 plus 3 9, 9 plus 2 11. That is 11 divided by 60. What is here? 1 by Rp, not Rp. So which implies Rp will be is equal to 60 divided by 11 ohms. 60 by 11 means how much it will be? 11 5 is 55. 11 5 is 55. 60 minus 55, 50. 50 means 11 4 is 44. Yeah. 11 4 is 44. Yes. 5.4 ohms. This is a parallel combination. Resistance, equivalent resistance. So draw the circuit diagram over, find the total resistance also over, and calculate the electric current. Generally, they will ask like this only, they will combine Ohm's law and combination of resistance also. So to calculate the electric current, what happens? I will be is equal to V divided by R. How much is the voltage? 10 divided. What is the R? 11 by 60 or 60 by 11 you can take, or 5.4 also you can take. If I take 60 by 11, 60 divided by 11, 11 goes up, it becomes 110 divided by 60, 0 0 cancels, 6 1 is 6, 6 to the 12, so 6 1 is 6, 11 minus 6, 50, 50 means 50, 6 8 is 48, 1.8 amperes. So this one will be the answer for this next question. Now see, this is about series and parallel combination. Until now, this question was only maximum resistance series combination. This question was only parallel combination. This question is also only parallel combination. This question is now combination of series and parallel combination. How to solve problems on series and parallel combination? When there is a problem asked on both series and parallel, not series, not parallel, together they asked. How to solve now? First solve this circuit. See, here a resistance R and two resistances are given. Like this. This is also R and this is also R and this is also R. R parallel combination first, and again to this one series combination. These two you solve first. R and R parallel combination, what will come? It will come R by 2. Remember the formula R divided by N. N, how many are there here? 2 are there. So it becomes this combination only. Imagine this as X, Y, this let imagine as A. So here X, A will not alter anything. But A and Y, it will become R by 2 now. So now these two are in series. When two resistors are connected in series, what happens? R1 plus R2. So R plus R by 2. R plus R by 2. It is going to be LCM going to be 1, and here 2R plus R. It is going to 2R plus AR. 2R plus 3R divided by 2. It is going to be single resistance. It is going to be 3R by 2, or you can write directly 1.5R. Okay. Next problem let us take. Now see this question, you see once. If four identical resistors of resistance 8 ohm are first connected in series so as to give an effective resistance of Rs, and then connected in parallel so as to give an effective resistance of Rp, ratio of Rs and Rp. Let us solve this question, a good question. See once. Four resistors are there, each of 8 ohm, first connected in series. So Rs will be is equal to N into R. How many are there? 4 resistances are there. What is the value of each resistance? 8. 4 8 is 32. So Rs is 32 ohms. Okay. What is Rp formula? Rp formula is R divided by N. See, why are we using these two formulas? Because they said here identical resistances. When identical resistances are there, then you can use Rs is equal to N into R and Rp is equal to R divided by N. So Rp is equal to R by N. R is 8 divided by N is 4. 8 by 4 is 2 ohm. Now they asked us to find the ratio Rs divided by Rp. RS divided by RP. RS is how much? 32. RP is how much? 2. 32 by 2, 16. So answer will be 16. Okay. Let us go to next question. Now see here. So how would you connect three resistances, each of 6 ohm, so that the combination has resistance of 9 ohm? How will you connect? Three resistors are there. Each resistance value is 6 ohm and the combination should have a resistance of 9 ohm. This type of question also they ask 2-3 times in the board examination. Means you will be having three resistances like this, like this, like this, like this. Each resistance value is 6 ohm and 6 ohm and 6 ohm. You have to connect this in any way you want, you can connect. Okay, and the equivalent resistance should be 9 ohm. Mind should work sharply. How to write 9 ohm? 9 can be written as 6 plus 3. Correct? When there is when this types of question comes, what value you have to find out that can be written in terms of the given values. How to write that should be running in your mind, that should spark in your mind. So 9 can be written as 6 plus 3. How to get 3 now? When 2 or 6, when two 6 ohms are connected in parallel, 6 by 2, 3 we will get. And 1 6 ohms means these two should be connected in series. First obtain 3 ohm resistance. How will you get 3 ohm resistance? When two 6 ohm resistances are connected in parallel like this, 6 ohm and 6 ohm, you will get 3 ohm resistance. For this 6 should be added. Correct? So for this 6 should be added means this should be in series connection to this combination. This is 6 ohm and this is 6 ohm, 6 ohm. Now this two combination will give 3 ohms. This will give 6 ohms. 6 plus 3, 9 ohms. Understood or not? And also to justify your answer. How will you justify your answer? You can write in words that when two 6 ohm resistances are connected in parallel, the equivalent resistance of this combination will be 3 ohms, and now 3 and 6 will be connected in series. 3 and plus 6 becomes 9. Generally I used to give the justification nicely by writing on my own, but video will become so lengthy, so I am not giving you the justification writing here. Let us go to the next question. See once, three resistors 6 ohm, 4 ohm and 4 ohm are connected together so that the total resistance is 8 ohm. Draw a diagram to show this arrangement and give reason to justify your answer. Now the same question. See, let us solve this question now. What they asked? Three resistors 6 ohm, 4 ohm, 4 ohm. What do we want? We want 8. Correct? 8 can be written as, we have 6 and 4. Correct? 8 can be written as 6 plus 2. Correct? How to get this 2 ohm now? 4 and 4 connected in parallel, 2 are there. 4 and 4 connected in parallel, we will get to 2 and connected in series to 6. Then we will get 8. So what will be the combination now? Combination will be like this. This one will be 6 ohm resistance and 2 4 ohm resistances will be connected in parallel. This is 4 ohm and this is 4 ohm. Like this and like this. This one will be the combination. Justification I feel you can give. Now let us look at this question next. By this time you should be able to solve these questions by on your own. So I am going to give you explanation directly. We have to find the equivalent resistance of this circuit diagram. 8 and 8, 4. 8 and 8 parallel becomes 4. 4 plus 16, 20. 20 plus 6, 26. 26 plus 4, 30. So equivalent resistance of this circuit diagram is 30 ohm. And if they ask you to find current, R is equal to 30 ohms, V is equal to 6 volts, then I will be is equal to V divided by R. V is 6 divided by R is 30. 1 by 5. 6 ones are 6 fives are. Correct? 1 by 5 is 0.2 amperes. I hope the answer is clear. Go to next question. Now let us look at this question. Now, how to solve this one? These two are in series. Whenever you get any question, first look at the where you can simplify. Where you can simplify, these two are in series. So these two you add up, you will get 12 ohms here. Afterwards, this 12 and this 6 will be in parallel. I will solve this question for you neatly, step by step. Afterwards, you can understand. Name the resistances. I will draw the circuit diagram here first. Right here. This is 6 ohm and this is 6 ohm. This is 6 ohm and this is 3 ohm and this is 3 ohm. The total combination is given to 4.5 volts. They asked us to find the resistance and the current flowing in the circuit diagram. Okay. Now let us solve this question. Name this one as R1, this one as R2, R3, R4, R5. Okay. So now first step, R4 and R5 are in series. R4 and R5 are in series. So we can take it as R6 is equal to R4 plus R5 is equal to 6 plus 6, that is equal to 12 ohm. So these two can be replaced by new resistance. That new resistance name I gave as R6. So the circuit will become how now? My diagram is very poor with pen, but you people don't draw like this. Please use pencil and scale and draw neatly. If I use pencil and scale, video will become lengthy and you have to spend so much time on this watching one video only. 6 ohm, 3 ohm, 3 ohm, 6 plus 6, this one will become 12 ohm. This one is R1, R2, R3. The new resistance is now R6. Because I have given resistance names 1, 2, 3, 4, 5, new resistance came, so I took it as R6. And the whole thing is connected to 4.5 volts. Now R6 and R2 are in parallel. R6 and R2 are in parallel. Write the same thing now. Write the same thing. R6 and R2 are in parallel. So 1 by, I'll give the name as R7. 1 by R7 is equal to 1 by R6 plus 1 by R2. So 1 by R7 is equal to 1 by R6 is how much? 12 plus 1 by R2 is, don't get confused because of these names 1, 2, 3, 4, 5, 6. It is very simple. I just gave names. You can give names as RA, RB, RC also. Nobody will question anything. So 1 by 12 plus 1 by 6. Just to solve this one, we are going to get as R7 is equal to 4 ohms. Solve this one in the method that I solved before. So now these two can be replaced and one resistance can be placed, that is R7. So this is R7 and this is R3 and this is R1. This value is 3 ohm, this value is 4 ohm and this value is 3 ohm. So now R1, R7, R3 are in series. R1, R7, R3 are in series. So R1 plus R7 plus R3. Let us name the equivalent resistance, final resistance we are going to get now. R8 is equal to R1 plus R7 plus R3. Then 3 plus 4 plus 3. 3 plus 4, 7. 7 plus 3, 10 ohm. The equivalent resistance of the whole combination is 10 ohm. And if they ask you to find the current, I is equal to V divided by R. V is 4.5. So I is equal to V is 4.5 divided by R is 10. So I will be is equal to 0.45 amperes. Okay. This is how you need to solve the question. Let us take one more question. Next question. This. See. 10 plus 10, 20. Correct? This one are in series. 10 plus 10, 20. 20 and 20 parallel. So this whole combination will give a resistance of 10 ohms. 10 ohms. Now this circuit will become 10 ohms, 10 ohms, 10 ohms. This whole will be removed now. This whole will be removed and 10 ohm resistance will be there. 10 ohm, 10 ohm, 20 ohm. So total resistance will be 40 ohm. Next. This one also simple. 10 plus 50, 60. Correct? 60 and 30 in parallel. 10 plus 50, 60. This whole two resistance can be removed and one resistance will be placed. That resistance will be 60 ohm. 60 and 30 are in parallel. Then the equivalent resistance will be 20 ohm. We are going to get this as 20 ohm. Next. Same. Now when a voltmeter comes, what to do? Nothing you can change. You no need to do anything. See, voltmeter or ammeter when they place, it is not that because of addition of meters the circuit parameters are going to change. No parameters of circuit is going to change when you add any meter. So if voltmeter and ammeter is added also, there will be no difference. You can remove these two instruments and you can do the same method only. If you want to do the same method, see 4 and 6 are connected in series, correct? 4 and 6 are connected in series, so these two combination will become 10 ohms. 10 and 10 are in parallel, so when 10 and 10 are in parallel, it will become 5 ohms. So this whole combination will become as 5 ohm. So 5 ohms, 5 ohms connected in series, 10. 10 ohms and one more 10 ohms connected in series, 20. So total resistance will be 20 ohm. See, observe neatly. 4 and 6. 4, 6 connected in series, so 10. 10, 10 in parallel, so 5. 5, this whole combination becomes 5. 5 plus 5, 10. 10 plus 10, 20. So the whole resistance will be 20 ohms. One more problem. These all questions are asked in the board examination. At the end, we will have a very good question which children will make, so many children will make mistake. We are already very soon. So now see here, 5 plus 10, 15, 15 plus 15, 30. Correct? This whole becomes 30 ohms. 10 plus 20, 30, 30 plus 30, 60. This whole becomes 60 ohms. 30 and 60 are there, 20. This whole combination becomes 20 ohms. And 20, 20, 40, 40 plus 15, 55, 55 plus 5, 60. 60 ohms is the answer. Now, this one see. 2 and 2. What they asked, how many resistance combinations has 1 ohm as the equivalent? 2 and 2 parallel, 2 by 2, 1. 3 ohms, 3 are there. R by N, 3 by 3, 1 ohm. Now this one you see, 2 plus 4, 6, 3 plus 3, 6. 2 plus 4, 6, 3 plus 3, 6. 6 by 2, 3 ohms. 0.5 divided by 2, 0.25. So only 1 and 2 has the equivalent resistance of 1 ohm. This is going to be the last question in a previous year asked questions. How to solve this question now? this question. See once. We have to find out the equivalent resistance of this circuit. What did I tell? I told that when there is a wire like this and there is no equipment connected, however they want, when there is a wire like this, like this, any wire, if there is no equipment connected, it can be removed, correct? So now upon this they framed a question. See, first this is 2 ohm, this is 3 ohm, this is 6 ohm, and they connected from here to here like this, and they connected from here to here like this. This terminal they named as X and this terminal they named as Y. We have to find out the equivalent resistance of the circuit like this. Sir, battery you removed, sir. No problem, pa. If we remove battery also, equivalent resistance is not going to change. We have to find total resistance. See, now observe, if this is X and the whole wire there is no equipment here in between, means if this is X terminal and this also will be the terminal X. And now this is Y terminal. This Y terminal is directly connected here. So this also going to be terminal Y. Understood or not? I said when there is a wire and there is no electrical equipment connected in between, these two will be same. So here also there is no electrical equipment connected. So this one also will be X only, and here also there is no electrical equipment connected. So this one also will be Y only. Am I correct? So now we have to find the electrical resistance between X and Y. Take this terminal Y and take this terminal X and this terminal Y. This resistance, if you look at from X to Y, 2 ohms is connected. Okay. You connect 2 ohms resistance from X to Y. 2 ohm. And if this resistance, if you see from Y to X, 3 ohms is connected. Okay. From Y to X, like this. How much is connected? 3 ohm is connected. This you see from X to Y, 6 ohm is connected. Again from X to Y, 6 ohm is connected. This is X terminal and this is Y terminal. How are they connected? They all are connected in parallel. They all are connected in parallel. So now you can know how to solve the parallel connection. Correct? So based on this, one more simple question I'll ask on my own. Find the equivalent resistance of the circuit between the terminals A and B. This whole wire is there, right? This terminal is A, and from here I have taken resistances like this. Like this. This resistance is R, 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 R. This is A terminal and this is B terminal. Okay. So now if you look at, it may be looking like a circle, but the whole terminal is A only because there is no electrical equipment connected around anywhere. So you can take this whole thing as A. And if you look at this resistance, this is also A, this is also A, this is also A, this is also A. So this is A, and we have to find the resistance between A and B. So I took A and I took B also. This resistance, if you look at from A to B connected R. This resistance also see A to B connected R. And you look at all the 4 resistances, all are connected A to B, R. 4 resistances. So equivalent resistance will be how much? R by N. N is 4, R by 4 ohms. If they give, instead of R, they gave 8 ohms, then what? 8 by 4, 2 ohms. Like that, you should be able to solve any question on combination of resistance. So by this, I hope you are very clear about the combination of resistances, and you can solve any question that is being asked on the combination of resistances. We have solved all questions from basic to maximum level questions. I have gone through 30 question papers and I have taken all combination of resistances problems. Hope this video helps you for your preparation. Thank you so much. We'll meet in the next video.